Here we have some rather tricky word problems. Let's take a look at these. It says, the first one says, the sum of the ages of Petra and her mother is 50. Let me look ahead to see what we're going to try to find. How old are Petra and her mother? So let's say Petra is P and her mother is M. So we'll use those two variables. That's their ages. And then it says the sum of the ages of Petra and her mother is 50. So first of all, I know P plus M equals 50. I also am guessing here that since I have two variables, I'm going to need a system of equations, two equations, to try to solve it. Let's see what else they give us here. Her mother is 8 years more than twice as old as Petra. Okay, we've got to try to sort out that sentence. We have an is in there, so that's probably our equal sign. And it says mother is. So mother is 8 years more than twice as old as Petra. Well, twice as old as Petra is just going to be 2 times Petra's age, so 2p. And 8 years more than that, we would just add 8. So there are our two equations, and this looks like it would be a good candidate for using substitution method. We already have m solved for 2p plus 8, so I could put 2p plus 8 up here in place of m. Let's try that. So this top equation would be rewritten as p plus, and then instead of m, 2p plus 8 equals 50. Combine the like terms here. P plus 2p is 3p plus 8 equals 50. And then we'll subtract 8 from both sides. We get 3p equals 42. And we'll divide both sides by 3. And I think we're going to get p equals 14. So Petra is 14. And her mom is 2p plus 8. So that would be 14 times 2. That's 28 plus 8. So mom is 36. All right, let's try one more. So this one says, while traveling in Spain, Deitch carefully peeked into his wallet and found that he had $60 in $10 and $5 bills. There were 3 fewer $10 bills than $5 bills. How many of each did Deitch have? So this is one of those money problems where you have different denominations. And the way that works is you come up with a variable for the number of each of those denominations. He's got $10 and $5 bills, so I'm going to call them T and F. So T would represent the number of $10 bills he has, and F would represent the number of $5 bills he has. And it says he's got $60 in those two. So these, if we want to find the value, we would take the $10 bills and multiply it by 10, and the $5 bills and multiply them by 5, and that would give us what they're worth. That's going to add up to 60. So we add those together, we get 60. So there's one of our equations here. It said if there were 3 fewer $10 bills than $5 bills. So that's our other clue. We've got to convert that into equation. There were 3 fewer $10 bills than $5 bills. So the number of $10 bills equals the number of $5 bills minus 3. That's 3 fewer than the number of $5 bills. So there are our two equations. We can use substitution again. We can put f minus 3 in for t up here. So let's try that. 10 times, and instead of t, we've got f minus 3 plus 5f. That equals 60. We'll distribute the 10 here. 10 times f is 10f. 10 times negative 3 is minus 30. Plus 5f equals 60. Combine our like terms. 10f and 5f is 15f. And then we're going to have to add 30 to both sides here to get the f term alone. So 15f equals 90. So 90 divided by 15. So f equals 6. And let's see, if f equals 6, then t must equal 6 minus 3, or 3. So he's got 6 $5 bills and 3 $10 bills to add up to $60. So that's a little bit of work with these tricky word problems.